Okay, so now we're going to talk about sample spaces and kind of our introduction um, to probability as well. So I'm going to get into the notes first, talk about those, and then I'll work backwards to show you a couple of sample spaces, including the one in the example. So on this slide, you first need to know that probability is the branch of mathematics that describes a pattern of chance outcomes. I already talked about that on the first day. That's really the foundational understanding of probability in this case, is that we're talking about chance outcomes when we're talking about probability. And obviously, this very many times happens again, that idea of the law of large numbers. In the short run, chance behavior is unpredictable, but it has a regular and predictable pattern in the long run. That's why you guys 2 days ago talked about long run probabilities. Like in the long run, we expect the probability to be a certain value, but in the short run, it's very unpredictable and really anything could happen. I want you to understand that probabilities are going to take the form of a number between 0 and 1. This would be like 0% of the time. This would be 100% of the time if you're moving it to percentages. But probabilities are always going to be a number between 0 and 1. Okay, so like 0.15. If something happens 0.15, the probability is 0.15. It would mean that it happens 15% of the time. So that's the idea of probability. Okay, we're going to get into, so obviously there's a lot of uses of probability. I'm going to actually skip this whole idea of independence. We'll come back to that and circle back in quarter 3 when we talk about dependent events. We're only looking at independent events this time, so there's no need to really go over the difference at this stage. But I want to start by talking about sample spaces. So sample spaces are going to provide us a good opportunity for actually getting the probability models for these. It says probability model down here, but I'll talk about that. In each event that we're going to talk about, it's really important to know what your outcomes could be. Like, for example, tossing a coin, my sample space takes shape like this. My sample space is that I could get a heads or a tails. Those are my 2 outcomes. That's really what a sample space is the number of possible outcomes that you could have. That's a very small sample space. So let me talk about another one. If I'm rolling 2 die, the sample space for that is actually, there are 36 different numbers that you can get. In fact, I'm going to show you that so that you can see it. Rolling 2 die, 2 dice and probability. So if you look at that, I'm going to pull that up and I'll show you what you could get. So here's a good visual for it. In this one, this shows the probability of, or the sample space of the different values that I could get. I could get snake eyes, which would result in a 2. I could get, and then it kind of works across this way, I could get a 2 and a 1 or a 1 and a 2, and that would result in a 3. Then you have these ones right here where I could get a 3 and a 1, a 2 and a 2, or a 1 and a 3, and that would result in a value of 4, and so on and so forth. I'm going to actually go back so that you can see the numerical values for this. You can see the numerical values for it, and there they are. If you get a 1 on one die and a 1 on the other, you get a 2. A 1 on one die, a 2 on the other, you have a 3, and so on and so forth. So that's how I was showing you that. You can see why lucky sevens is a commonly used phrase when you've seen maybe gambling of any kind on movies or TV. And lucky sevens, the reason they say that is because it is the most likely event when you're rolling 2 die. You have 1, 2, 3, 4, 5, 6 times, or 6 different ways that you can roll a 7. Okay, you can roll a 7, a 6 on one die, a 1, a 5, and a 2. Okay, so you have 6 different ways, which happens the most frequent, 6 out of 36 or 1 in 6 chance of getting a 7, of rolling a 7. And that one is your least, or your most likely. The sample space for this though, I would not want you guys to list 2, 3, 3, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6. I don't want that listed. Instead, we list that sample space like this. We omit any kinds of repeats. So we would list for for rolling 2 dice, you can get a 2, a 3, a 4, a 5, a 6, a 7, 8, 9, 10, 11, or a 12. And that's the most that you could get. So then I could ask specific questions like, what is the probability of rolling a 9? What is the probability? Once I've actually created that sample space, you guys could say, well, the probability of rolling a 9 is 1, 2, 3, 4 in 36 different outcomes. 4 in 36 outcomes. Or what is the probability of rolling snake eyes? Okay, biggest payouts come from either your snake eyes or double sixes. Okay, those are the biggest payouts on gambling when you guys are like playing craps or any others that involve dice. And the reason is they are the least probable. There is only a 1 in 36 chance of getting a 2 and a 1 in 36 chance of getting a 12. So it's that kind of probability that we will be doing. Okay. So here's another sample space. Today we're really focusing on sample spaces and building them. If I were to flip a coin and roll a die, the different outcomes would be a heads 1, heads 2, 3, 4, 5, 6, or a tails 1 through 6. That's all the different things that could happen. Tree diagrams can help as well, and I'm going to show you one of those on your actual example, but a tree diagram can help you build these. So I put one more here, and you can see it's pretty cumbersome, but this one right here, when you're tossing 4 coins, there's actually 16 possibilities, and this is really important for you to understand too. I have this here. I have 2 times 2 times 2 times 2. The way that you would know how many outcomes there are going to be before you even go into it is that if you think about flipping a coin 4 times, there are 2 different outcomes for the first toss, 2 different outcomes for the second, 2 for the third, and 2 for the fourth. So there are going to be 2 times 2 times 2 times 2 outcomes. There are 16 possibilities. I'm going to list those here, which I've done, but I want to go back to this one really quick. I knew going into this that my sample space would be flipping a coin, 2 different outcomes, rolling a die, 6 outcomes. 2 times 6 is 12 different ones that I was going to list, and there are 12 here. So going into problems, it's important that you do that so you know how many outcomes there are. I should have 16 here. Let me explain how this could go down. I could have 4 heads, right? I put the number of heads here on the top. I could have 4 heads where all of them were heads. That's going to be the least probable along with all tails, right? Then I could have 3 heads. I could have heads, 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 tails. Heads, heads, tails, heads. Heads, tails, heads, heads. You can see I'm just moving that tails around. I could have 2 heads, 2 tails. That's all the different ways that can happen. I could have just 1 heads and then the rest tails, and I move that heads around. Or I could have no heads at all and I have all tails. What we're going to be doing moving forward is assigning probabilities to these sample spaces. So the probability of having 4 heads is going to be a 1 in 16 chance. The probability of having 3 heads is going to be a 4 in 16 chance. The probability of having 2 heads will be a 6 in 16 chance. The probability of having 1 head is going to be a 4 in 16 chance, and the probability of having none at all, no heads at all, will be a 1 in 16 chance. And that is all we're going to talk about today. So if you need help with the homework, then you can go ahead and go to homework help, and I will have problems with sample spaces for tonight's work.